Now let's talk about what kind of information we can get out of an equation for a simple harmonic oscillator. So suppose I have x of t equals 0.10 meters, which cosine pi times t plus pi over 3. Well, just based on what you've learned about kinematics, you should know that if you have an equation for position as a function of time, you can then get out an equation for velocity as a function of time. That's just the first derivative of the x, or position as a function of time. So if I take the first derivative of this, I'll get my constant back out, 0.10 meters, multiplicative constant back out, that is, times cosine, and the cosine does have t as part of its argument, so I know that I will get out negative sine, and then pi t plus pi over 3. Okay, now by the chain rule, I have to take the derivative of what's inside here, and that would just be pi, derivative with respect to time, that is. And if I grab a handy-dandy calculator, I could answer questions about different times. So I could tell you, like, what's the velocity at 2 seconds. And so if I put in t equals 2 seconds here, I get back out negative 0.272 meters per second. I could similarly tell you about the acceleration as a function of time, which is just the second derivative of the position as a function of time. And luckily, I've already taken the first derivative, so that would be the first derivative of the velocity as a function of time. And if I take the derivative with respect to time here, I'm going to rearrange my constants a bit. So this is negative 0.10 meters times pi, and then the derivative of sine will give me back cosine pi t plus pi over 3. And then I'll get another pi out of this, so that's squared. And if I say wanted to know what's my acceleration at 4 seconds, I could plug in 4 here, that's the time, and get out negative 0.493 meters per second squared.